Hi there, thanks for joining us. This is Space Nuts. My name is Andrew Dunkley. It's really good to have your company yet again for this episode 341. Coming up this week, we're going to be talking about aurorae. They are being seen in places they're not usually visible from, including my town here. There's been reports of people seeing them. So we'll talk about that. We'll talk about something that's happening in the centre of our galaxy that involves spaghetti and possibly a tossed salad. We'll find out. We'll also be answering audience questions about the speed of light, the Big Bang, and our obsession with Mars. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us, as always, is his good self, Professor Fred Watson, live from Europe. Hello, Fred.
Hello, Andrew. I'm joining you live from Munich.
Munich?
Yes.
Wow.
Munich in Bavaria.
Das ist gut, ja?
Yeah, that is sehr gut. Thank you.
Sehr gut, yeah.
Yeah. So, yeah, we shouldn't do that, really, should we?
No, we'll probably get scolded for that one.
Yes, but it's just, I'm sorry.
It's one of the easiest accents to replicate, though, I find. Although if I do it for too long, it turns into French.
Well, I'm sure we've upset people. But I think Peter Sellers was the master of the German.
Oh, wasn't he? Wasn't he?
Yes.
Indeed.
Yes,
So you are there, like you were in Vienna a couple of weeks ago. Now you're in Munich. What's happening there?
There is a conference which is at the headquarters of the European Southern Observatory, which are in a suburb of Munich called Garching, which is where I am at the moment, in a hotel, which is actually very comfortable. Thank you. So the conference is entitled Coordinated Surveys of the Southern Sky, or CSSSS. And it's about, well, the name really tells you all of it, because it's a joint venture between the European Southern Observatory, which runs the biggest and best optical or visible light telescopes in the Southern Hemisphere, and the Square Kilometre Array Observatory, which you and I have often talked about. Half of it's going to be in Australia, half of it's going to be in South Africa, and these two facilities are going to be the world's best in the Southern Hemisphere. And so one's radio, one is visible light. How can you use them both to the best advantage and combine, almost combine their resources by bringing to astronomical discovery to a new dimension? So that the radio, what you see in the radio waves, what you see in the visible light, bring them together and learn more about the universe. And in fact, one of the really interesting aspects of this, as I was saying to you a few minutes ago, I chaired a discussion session this afternoon, which I have to say, between you and me, and this must go no further, scared the pants off me, because I was talking to my professional peers on a subject that they knew far, far more about than I did. But somehow it all kind of hung together, and we ended up with, I think, a good discussion. At least nobody's told me it wasn't. So they might just be saying, oh, well, we won't say anything to Fred. I don't think it was that. What we ended up talking about was how you combine. So by a survey, what I mean is making lots and lots of observations, not necessarily just of where things are in the sky, but perhaps their velocities, perhaps their for galaxies, their rotation and things of that sort. You make all those observations, but the radio people do that as well. And what you want to do is cross-reference them so that your positions of your objects seen in visible light telescopes match the positions of the same objects seen in radio telescopes. And when you're looking in the most exquisite detail, which these facilities will be doing, that's not a trivial problem. And that's actually where we ended up with the discussion, which was, I thought, quite interesting. So It's been a great week, and you're quite right. 2 and 3 weeks ago, I was in Vienna at the UN, representing Australia, along with colleagues, were other delegates, at the COPWAS meeting, the Committee on the Peaceful Uses of Outer Space, talking about dark and quiet skies. But in between, I had a week in the UK, and I think you and I talked from there too.
Yes, we did, from Scotland.
From Scotland. I can't do that accent and upset another lot of people there. Hey, born in Scotland. That's where my daughters live, and that's where I was. So lovely.
Lovely. Oh, it must have been great to catch up with family.
It's been brilliant. It's been a fantastic trip. Thank you, Andrew.
Yeah, I think these days families are much more fragmented than ever in human history because it's so easy to move around and get jobs in other places, and it's quite an interesting time that we live in. Just in terms of public speaking, do you enjoy it, or are you one of these people that is scared witless by it?
I'm always nervous, I have to say. I do a lot of talking in front of people, and maybe that's what saved me today, because I can kind of say moderately cheerful things, even if I'm thinking, what are we going to say next?
Yeah.
And that worked well. So I do relish it, honestly. And I'm sure it's like you with broadcasting, Andrew. It's something that's totally addictive. Once you've done it for 30 years or 40 years, you just can't stop.
It's funny, talking on the radio, of course, when I first started and under certain circumstances, you get a bit nervous if you're interviewing someone super important or super famous, or you've got a new station and you're doing your first show, that sort of thing. But once you get the hang of it, you don't get nervous or uptight or worried or scared. But at the same time, I was always fearful of public speaking face to face.
Oh, that's interesting.
But I eventually got used to it. It's just like anything. You get exposed to it long enough, you learn how to deal with it. And I rarely get nervous now in front of an audience. I mean, if there were 700,000, I'd probably have a twinge. But, I do enjoy it. I really do enjoy getting up in front of a crowd and having a chat.
Yeah.
It's one of my favourite things. And I don't get to do it very often, not like you. You get to do it all the time, but not something common in my life. But when the opportunity arises, I usually jump right on it.
Sure you will.
So you wrap up there this week and head home?
Yeah, head home on Friday and back in Sydney late on Saturday evening, I think. Yes.
Right. Well, so we're keeping you up tonight so you can get adjusted to the jet lag.
Quite so. So you're doing me a favour, really.
It's nearly midnight there, isn't it?
Yes, it is. Yeah, quarter to 12. That's all right.
Good grief.
It's okay. You're talking to an astronomer who used to stay up all night, 5 nights a month. So
I accounted for that, and I used to do midnight to dawn radio when that was a thing, and they didn't have automatic systems. But used to live on the opposite side of the world timeline wise. Now, all right. Well, it sounds like the conference is going very well, and we'll hear some more stories when you get back, I'm sure. But let's talk about these auroral displays, because there's some interesting things happening. Normally, you'd have to travel to points very remote on Earth to see aurorae, and you've taken tours up north to see them. But right now, people are seeing them in places where you wouldn't normally catch them, including Dubbo, which is normally way too far north. We're in central New South Wales, and people have taken photos of the Aurora australis. What's going on? It's these sort of bubbles of plasma that get spat out from the sun are what we're experiencing at the moment. So we're not in a regime of having intense solar flares that are threatening all the satellites in orbit and all the power grids of the world. But we do have a fairly active sun at the moment, and in some ways that's not surprising, Andrew, because we're approaching something called the solar maximum. You and I have spoken before about what's called the solar cycle, which is not a sun-powered bicycle. It's the regular up and down trend in the number of sunspots that appear on the sun. It's been something that's been basically noted for centuries, but we now know that those sunspots are highly intense regions of magnetism on the sun's visible surface, and they tend to release energy in the form of these basically plasma bubbles, they're sometimes called. I tend to think of it more as a wind of subatomic particles, which then interact with Earth's atmosphere around the magnetic poles and cause the
green and red and sometimes purple lights of the aurora. So
I'm looking at a photo now that was taken in my region. It's been published on the ABC website.
Yes,
I hope they don't mind us sharing this for our YouTube audience. But if you can see that, sorry, I can't get the reflection of everything out of it. But I'll shut that for a minute. There,
Yeah.
can you see that?
I can. Yes, that's right.
Yeah, that looks fantastic,
great.
doesn't
yes,
it?
Yes, it does. Terrific.
I don't know why they needed an ambulance, but that's okay. But that's what people are seeing. It's a beautiful pink, that one.
It's a pink, that's right. And so what you're seeing there, and I actually have seen the same thing from further north than you when I used to live in Coonabarabran, 150 kilometres north of...
Further north, yeah.
Yeah, we occasionally would see the aurora from there, possibly because we've got dark skies, a bit of altitude. Yeah, that's right. But it was the pink. And that's because what's happening is you're looking to the south, and if you think of the curvature of the Earth, what that's doing is where the aurora itself is happening, you're below the horizon, and that aurora is sticking up above the horizon. So the red stuff is from oxygen atoms, which are being excited at heights in excess of 100 kilometers. So between about 160 and 320 kilometers above the surface, that's the top end of the aurora. That's oxygen, but it's being excited in a different way. The point is that at those heights, above 100 kilometers, roughly 100, maybe 150, 160 kilometers, the pressure is lower than it is at 100 kilometers. There's not much air there at all, but above 100 kilometers, there's enough that the aurora basically excites the atmosphere to glow green, but above that it glows red. So it's still oxygen that you're seeing, but it's glowing red. And the reason why we see these red aurorae at latitudes like Dubbo, like Coonabarabran, is that the green is below the horizon. So you don't see anything of the green. All you see is these high red streamers from the oxygen at heights above about 160 kilometres.
I believe the same thing's happening in the Northern Hemisphere because they've got reports of sightings in England. Is that unusual?
Yeah, yes, it is. It is unusual. And you've made a very good point there, and that is that the aurorae are symmetrical. So if you get an activity, auroral activity in the Northern Hemisphere, you get it in the Southern Hemisphere as well. And that's because, generally speaking, it's the same blast of subatomic particles from the sun that's being funneled both to the North Magnetic Pole region and the South Magnetic Pole region. So you get similar activity in both. But yes, what is unusual is what's happening in, for example, the UK. So as you get more intense aurorae, they spread nearer the equator. That's the bottom line. They go to lower latitude, both lower, by lower I mean nearer to the equator in both hemispheres. Yeah. And so I know from actually colleagues I was speaking to this evening at the conference dinner that they're seeing aurorae in Oxford, which is pretty south in the British Isles, and so that's quite spectacular, and it's kind of parallels what you're seeing in the Dubbo area in Australia.
When's the best time to look? I mean, from our perspective, we'd have to look south. Yeah, at least I know that. But is there a good time to catch them? Because I read that this could go on for the next couple of years.
Yeah, might do. Well, that's because we're approaching the solar maximum, where we've got maximum numbers of sunspots. On the disk of the sun. So in terms of time of night, our experiences when we've led aurora expeditions up in the far north is often you will get a sort of fairly low level activity earlier in the night. In fact, when you're at really high latitudes, it starts off usually with a green band across the sky. There must be a joke in there about we're getting the band together, but I'll leave that one for now. So there's this green band. I've been practicing my dad jokes, Andrew.
Yeah, they're good.
Yeah, the green band across the sky, which sort of heralds the fact that you're going to get some activity, and then it gradually develops from there. And sometimes you get a lot of activity and everything looks really spectacular. Then it dies away, and then a bit later on it comes back again. So it's a question of being patient and watching. In terms of times of year, that's a really interesting question. Our Aurora expeditions have traditionally been midwinter in the Northern Hemisphere, and that's partly because it's such a charming time of the year to be in Lapland. There's snow everywhere. All the people in far northern Scandinavia know exactly how to deal with it. So all the vehicles have got studded tyres. The buildings are all properly heated, properly insulated, and it's just a delightful place to be. But it turns out that the Aurora numbers are actually most prominent, so that's just saying that perhaps your chances of seeing an aurora are better near the equinoxes, and we're not far from that now. We're approaching the autumn equinox here in the south, the spring equinox in the north, and that's a good time to look for aurorae.
Okay, I'm going to. I've got my new lenses, and I've got my. I don't know if I'll absolutely need a telescope, but I might be able to get a good pick if I can spot something. I want to give it a shake.
Yeah, well, you should do. Don't shake your camera, though. That's right.
Because we're on a hill here, and I've got a really good view south down my street.
That's right.
So I could stand in the middle of the road and get.
Trouble is, you've probably
picture.
got street lights as well, have you?
Oh, unfortunately, but they're pretty dim. Yeah, just like me. But they were,
Well, they're dim because they're in the the Arana region,
dark sky
area to protect the observatory.
Exactly,
100 kilometres away from you. That's
right. Okay, so people should get out and about and see what they can see and share their pictures on the Space Nuts podcast group Facebook page, because I'd love to see what you come up with.
Yep,
and share them with everyone.
While we're talking about looking at the sky, it's only a few days. It's only going to be for a few days yet, but Venus and Jupiter are very close together in the evening sky and look really spectacular at the moment.
Okay, I might get my new Barlow lens out and give it a whiz this weekend. Yeah, I've got another one. I keep getting stuff. I don't know what I'm doing, but I keep getting stuff.
You're doing the right stuff. Yeah. Now
we'll wrap up this segment. You mentioned getting the band back together as a dad joke. All right, I've got one for you. This is a science-based dad joke I saw the other day. I follow a dad joke Facebook page. I love it.
Why does that not surprise me?
It's so terrible. But this one, my granddaughter was doing science at school, and they've got to do a project on Galileo. And she said, "Pop, can you tell me anything about Galileo?" I said, "Galileo, he's just a poor boy from a poor family."
And it went right over her head, I guess.
Of course it did. Yeah. That's just, oh, gosh. I love that one. That's brilliant.
Yeah.
All right. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Yeah, that'd be us. And good to have your company. Now let's move on to something akin to Italian food, but probably tastes much worse. Spaghettification. Now, this is where a black hole tears something to shreds, and it looks like it's happening to a gas cloud at the centre of our galaxy.
Yeah, this is a great story, Andrew.
Not for the gas cloud, it's not.
No. But, you and I have talked ad infinitum probably about spaghettification, this phenomenon that happens to anything that gets near a black hole, where one side of it feels more gravitational force than the other. Technically known as tidal distortion, but what it means is you get drawn out into something like spaghetti, which doesn't sit well with humans. But we've now got evidence of this actually happening, and kind of in a way a sort of ringside seat. Now, there's 2 groups of scientists, one based about a 2-minute walk from where I'm sitting now, in the Max Planck Institute for Astrophysics, which is right next door to the hotel I'm in at the moment. And the other one is in California at the University of California, Los Angeles. And these 2 groups of scientists, both groups have been awarded a Nobel Prize in the last, I think it was the 2020 Nobel Prize. Because for the last 20 or so years, in fact, rather more than 20 years, both these groups have been observing with big telescopes the center of our galaxy, the region around the supermassive black hole, using infrared to penetrate the dust, because that is a very dusty region of space. And they've been watching stars orbiting around, well, nothing, because that's what it looks like, but it's actually the black hole. But what they've also picked up, and it's been observed, I think, for 20 years now, is an object which rejoices in the marvelous name of X7. X7 is a cloud, it's an odd cloud of gas. It's about 50 times the mass of the Earth, and it's basically in an orbit around the black hole, which we have told people before is called Sagittarius A star. That's actually the name of the radio source that is caused by the black hole itself. Yep. So this thing's in an orbit that brings it close to the black hole. And what that does, because of this effect of one side of it feeling more force than the other, it basically stretches it out, spaghettifies it. And in actual fact, it will probably disintegrate when it has passed closest to the black hole, which will happen in 2036. So it's
that's a lot sooner than I would have expected.
Yeah, 2036 is doable, isn't it? I mean, we'll be still spinning the yarn by then, I'm sure.
For sure.
So there's observations which have come actually from the California group of this object, and they use the telescopes of the Keck Observatory, which is on Mauna Kea and the island of Hawaii. The Max Planck Institute group use, of course, the telescopes of the European Southern Observatory, as I said, which is where I'm meeting for this conference. So it's really great stuff. This is right at the cutting edge of our understanding of how things behave in the region of a black hole. And what it does is gives you a marvelous opportunity to check our understanding of gravity, which, of course, comes from Einstein's general theory of relativity. We're kind of trying to pick holes in relativity, because the scientific world believes that there's something else that's better than relativity that we haven't got to yet. So people are looking for the gaps in relativity. And one way of testing that is to look at objects behaving in very, very intense gravitational fields. And that's what you get around a supermassive black hole, like the one in the middle of our galaxy.
Objects behaving badly.
Exactly. Quite so.
And yet it was an area that was invisible to us for so very long because of all the stuff in the way that is blocking the light.
Yeah, that's right. I was actually in my, kind of mumblings this afternoon, or my ramblings perhaps is a better word. I mentioned that I had, as a young scientist, that's 50 years ago, I'd been trying to observe through the stars of the center of our galaxy to see if we could see other galaxies on the other side. But that it's such a dusty region. There is so much dust there that you can't even see the stars in the center of the galaxy. And without infrared telescopes, of which we now have many, that certainly when I started as an astronomer, they were a rarity. But the infrared telescopes can penetrate that dust. And that's how these effectively movies of the motion of stars and things like X7 have been plotted going around the supermassive black hole at the center of the galaxy, because they're made with infrared radiation detectors on these giant telescopes. So, I think this is a brilliant story. It's one I've been following, as I said, for probably 15 to 16 years, and it just gets more exciting all the time.
We need more black holes so that we can clean the place up.
That's what will happen to X7. It will be probably gobbled up by the black hole itself, maybe not in 2036, but perhaps not too far afterwards. And that might produce an outburst of, energy from the black hole at the center of the galaxy as this material spins into the accretion disk around it and gets accelerated to super high velocities, which means that it releases a lot of energy. So that's something to look forward to, perhaps by the younger members of this audience, if there are any, because I don't know how long it's going to take, but I think it's a really exciting thing to postulate in the future.
Yes, and that spaghettification will be, you reckon, 2036-ish?
Yes, that's when it passes closest to the black hole. So I don't give much for its chances of making it around the black hole. No,
probably not. Okay, let's move on to just another topic. It's sort of a review because we've known about this issue since late last year when the International Space Station was damaged by micrometeoroids and suffered an outgassing of one type, and they've just actually sent a rescue mission to the ISS. It was a Soyuz unmanned or uncrewed probe they've sent up there, which I believe has now arrived.
Yes, that's right. So exactly as you say, it was back in December, in fact mid-December last year, that we had this curious phenomenon of a radiator leaking its coolant into space from the Soyuz spacecraft docked with the International Space Station. And the sort of consensus opinion is that was due to a micrometeoroid hitting one of the cooling pipes, and it caused this leak to happen. Now, the Roscosmos, the Russian space agency, very quickly established that rendered that Soyuz vehicle unreliable for to transport cosmonauts and one astronaut back to Earth, because this is the way it works. Basically the Russian astronauts, often with an American or other nationality passenger, they go up to the space station in their Soyuz vehicles. The American-based ones go up in their Crew Dragon vehicles, but you don't interchange them. So if you don't have the Soyuz vehicle that you came up in, you can't get back to Earth. So they said at the time that they were going to mount a sort of rescue mission by sending up another Soyuz spacecraft uncrewed, as you said, to dock with the International Space Station to bring these scientists home. It's actually two Roscosmos cosmonauts, Sergei Prokopiev and Dmitry Petelin, and an American astronaut, Frank Rubio, will come back in that new Soyuz spacecraft that's now docked. I'm not sure when that is going to be, but the damaged one is going to be returned to Earth robotically. So it will actually land with its parachute-assisted, landing system in Kazakhstan, so that people can have a look at it and find out what the damage that was done by the micrometeoroid was.
Well, I suppose that's what you get when you use 1970s Ford radiators in your gear. And
actually, it's 1960s Ford radiators. That's when the Soyuz spacecraft were developed, and they've been fantastic workhorses. Actually, very reliable. Yeah.
Mm. All right. Well, it sounds like they've found a solution. This is what I love about space travel and getting out there in that what is essentially a very dangerous environment.
Yes,
they have problems and they find solutions. And there've been some extraordinary cases of that. Apollo 13, a case in point, but there's been many other near misses and a few other things that have been dealt with. Amazing people on the ground and in the air that deal with all these things. So we wish them well. Hope they make a safe return.
Yeah.
This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Okay, Fred, let's get into some audience questions. We've got a couple of audio questions and a text question to wrap it all up so you can go to bed. Oh, by the way, welcome to Thursday. It's Thursday there now. So you've caught up to me. Yes. We were talking on 2 different days there for a while.
Yes, we were. That's true.
Yeah. Now, our first question today comes from Sean. It's a double bunger.
Hello, Andrew and the jet-setting Professor Watson. This is Sean from Charleston, South Carolina, U.S. And my question is pertaining to speed of light. And you guys were talking about it the last episode. So we have to pretend for a minute that we're like standing on a platform for a train. and the train goes by, we see the train, and then the train whizzes by, and we see the back end of the train. If we were standing somewhere and a laser beam came on, and the laser beam was going right past us, and then the source of the laser beam was turned off, would we see the back end of the laser beam traveling through space, sort of like the train was leaving the station, so the light would be continuous? I know it sounds kind of crazy, but it's curious. And the second question is the center of the universe, where the Big Bang is, like, do we know where that is? Sort of like a bomb crater, where everything goes outwards. Do we know where that bomb crater is? So I hope my first question isn't too confusing. I love your show. And Professor Watson, enjoy your trip to Vienna. That's where my first stop on my honeymoon. And I hope you're flying in the front row. All right. Thank you very much.
Flying in the front row is very expensive. But a couple of questions there, Fred. I'm gathering that the train analogy is how he is describing the laser light as it passes us and then gets switched off. Is that how we would observe a laser if we could observe it at a speed that gives us a vision of it? That makes sense.
Yes and no. Look, thanks, Sean. Those are great questions. And so, I think it's reasonable to, the analogy of the train going past. And I was on a train about an hour ago to get back to my hotel. It wasn't traveling at the speed of light, but it was going pretty fast. So imagine that, but imagine that instead as the beam of light that's been shot out of a laser. Somebody's turned it on, the front end of that beam emerges, heads off at the speed of light, they turn it off, and the back end of the beam heads off, following the front end. Now, in a sense, you would intuitively think, yes, you'd see this spot of light disappearing into the distance. But because the light is traveling at the speed of light, the light, you've got to throw in one other thing here, by the way, and that is the medium within which this is traveling, because you won't see the beam of light if it's going through a vacuum. You don't see it. You only see it if it's lighting something up. So imagine it's going through dust or something. And you want to see the back end of it illuminating the dust as it disappears. You won't, because it's receding from you at the speed of light, so the light that it emits never gets to you. It's a bit like the galaxy horizon that we expect to find when the expansion of the universe carries galaxies beyond the horizon that we can't see them, because they're traveling away from us at a speed that means the light will never reach us. So I think it's analogous to that. So I think the answer is no. You won't see anything, which is a bit sad.
I suppose so. Where's the center of the universe was the second question. We've had that one before, and I think the answer is everywhere.
Yes. Well, I was going to say you're sitting in it. It's a bomb crater in your living room. It's one in my living room as well. And it's because the problem is that we tend to think of the Big Bang in terms of the sort of explosion that we see on TV. And we look at it from the outside, we see something happen, and yes, there's a crater where that bomb went off. But it's not like that from the point of view of space and time, partly because we think the universe began in a singularity. In other words, a point of zero dimensions. Now, that's very hard to get your head around. But when that explodes, so it's the usual story of the Big Bang is, first of all, there was nothing, and then it exploded. That's the way it is. There was some sort of event that took that singularity from being tiny to being very large very quickly. But because it's almost because the universe doesn't really have any known dimensions, that you can't identify anything as being the center. And because it started off as a point, everything is the center, because at one time everything was touching everything else. So there isn't really a definable center to it.
I'm pretty sure a lot of people would argue there had to be because there was nothing, there is no place originally when the Big Bang happened.
That's right. Yes, that's right.
So that's how we say it's everywhere. But I understand where they're coming from, because they're thinking, okay, if the universe is expanding in all directions in a sphere, there has to be a middle, and that's where it happened. But
yeah, and in a way, the middle is here, because the only observation we can make is of what's happening around us, and what we see is everything rushing away from us. But that doesn't mean we're at the middle, because if you were, it turns out that if you were somewhere else, 2 or 3 billion light years away, you'd see exactly the same thing, even though you're in a different place.
Okay. Confused, Sean? Because everyone else is.
I know.
Yeah, it's a bit of a weird one, that, but it's always good to.
Yeah.
It's a good one to go over again. Thank you, Sean. Lovely to hear from you. Let's go to Carmelo, who thinks we're all obsessed.
Andrew and Fred. Hi, this is Carmelo from Los Angeles, California. My question for both of you is, why is NASA and Elon Musk so obsessed with Mars? It just seems like a bad idea and perspective to terraforming. It seems like someone might get cancer from the levels of radiation that are happening there. It seems like a lifeless dust bowl, probably what the Earth will be like in about 1,000 years if we're lucky. Anyways, why are these people obsessed with Mars? Why aren't they more interested in Europa, Enceladus, Ganymede? They just discovered Ganymede has its own electromagnetic field. Titan has a nitrogen atmosphere, which, I'm not mistaken, would be really not easy, but be a lot easier than Mars to terraform. Anyways, that's my question. Why is everyone so obsessed with Mars? Is it because it's close? Because that seems kind of lazy. Also, what do you think of the show Avenue 5? I think it's kind of fantastic.
All right. Thank you, Camillo. I don't know. I've heard of the show, to be honest. I'll have to look it up. Was it Avenue 5?
I'll
see what I can find out.
Andrew, I definitely haven't. So
no.
The answer is no for that. But we can
Camillo,
do some research on it.
No opinion at the moment.
No.
But, the obsession with Mars. Yeah, I suppose you could call it an obsession. I do agree that it's probably proximity. It's probably easier to get to than everything else, and it's certainly much, you get there faster than if you had to try and, send people to Enceladus or something like that. So I think that's probably the reason. But I guess you could also say this is just a stepping stone. This is where we go to first. But ultimately, as we get better and better at what we do and simplify some of the problems associated with space travel, we will venture further. We're just not ready yet to go out to Ganymede or anywhere like that. That's my take on it.
Yeah. So your take, though, is specifically thinking about human spaceflight, Andrew.
Yes.
Which is, of course, an absolutely valid way. And in terms of Camilo's words there, I think we are obsessed with Mars, but I think there are very good reasons for it. So, but in terms of human spaceflight, it is by far the most Earth-like of all the environments around us in the solar system. There are some very interesting environments, some of which Camilo has named: Ganymede, Callisto, Europa, Titan, Enceladus. All of these are places which are of great interest from an astrobiological point of view. But if you want to take a ride there, you're facing even more, even more difficulties than you are with the journey to Mars. The journey to Mars is bad enough; it's going to be bad enough. But because when you get there, it is the most Earth-like environment in the solar system, and it isn't anything like the Earth, but it's more like the Earth than all the others. And yes, there's radiation issues. There's all of that. Elon is certainly very keen on the idea of sending many, many people to Mars, and that's why he's building his space starship. But I think the idea of colonizing Mars, which is certainly what Elon talks about, is a very bad idea. I think it's going to be. I would, expect to find that the consensus of opinion is that we should be treating Mars more like Antarctica, as a place where scientific expeditions go from time to time, but you're not opening bars there and turning it into a theme park or anything like that. So I don't think Mars will ever be like that. At least I hope not. But when you look at the robotic exploration of the solar system, then you're in a different regime. It's still much easier to get something to Mars. You can put rovers on the surface. You've got, just a quarter of an hour or something delay of the signal going one way and similarly coming back. You can even fly helicopters in its atmosphere. So it's a great place to explore, particularly for signs of past or even present life. And that's what Perseverance is doing. That's its mission, to look for signs of Martian life. There may well be life on the subsurface oceans of some of these moons of Jupiter and Saturn. And Titan is an astonishing place with its lakes of liquid hydrocarbons. I mean, that's just, it makes your spine tingle when you think about the environment that you've got in Titan. But it would be so much more difficult, not only to send humans there, which is certainly going to be hard, but even a robotic spacecraft. There are plans, though. There is a plan also to fly a helicopter in the atmosphere of Titan. It's the Dragonfly project. You can probably Google it and have a look at it. So we are kind of obsessed with those moons, but in terms of human space travel, I think Mars is really the only option at the moment.
Okay. And Carmelo, I looked it up, Avenue 5. It's a science fiction comedy series. Got some big names in it. It's been going since 2020. Hugh Laurie is in it.
Oh, Hugh Laurie. Sorry.
Yeah. And Zach Woods, and quite a few. Lenora Critchlow, I think that's how you pronounce the name. It's a good cast. I'll have to check that out. Thanks for the tip, Camilla.
And then you can let me know what it's about as well. I think it's on HBO, which we don't get directly in Australia. We have to watch HBO shows through another entity, which makes it much, much more complicated for us, unfortunately. But thanks, Camillo. We'll squeeze in one more quick question, Fred. This one comes from Doug. He said, I just found your podcast and I'm loving it. Oh, well, that's one. I am a park astronomer for the Brunel Dunes State Park in Idaho, USA. We currently have a 25-inch Dobsonian, and coming in May, we'll be introducing a new observatory that will house a plane-wave CDK 700 telescope. Wow, that's awesome. My question is, if you were able to draw, here we go again, if you were able to draw an image of our universe which included the location of where the Big Bang happened, what would it look like? Would the Big Bang explosion be in the center of a sphere, i.e. a balloon? If not, what would it look like? All we see are the early formations of galaxies just after the Big Bang. What about the early galaxies forming on the other side of the explosion? Is there another side? I hope this doesn't sound like a stupid question. No questions in astronomy are stupid. Doug, please don't put yourself there. It's a great question, and it sort of dovetails well with one we had earlier about the Big Bang from Sean. But he's saying from an observer's point of view, what would we see? Would we see a center point with an expanding sphere, balloon, whatever you want to call it? Yeah, so what you're asking us to do is put yourself outside the universe.
When it doesn't exist yet.
There isn't an outside to the universe. That's the thing. The only place where space exists is within the universe. Now, that's the standard picture of the way the universe works. If you're going to invoke higher dimensions and multiverses, then yes, maybe you could watch one universe come into being from another one. In which case it will be a very spectacular event. But even then, you're still not talking about normal space-time. I don't think you get, if you've got a fifth dimension, it could be a membrane or something like that. You're not going to see the way we would see, for example, an explosion from the outside. So it's really, as I said a few minutes ago, the only thing we observe is the universe expanding around us. And our assumption is that wherever you are in the universe, you'll see the same thing. You will always see that same expansion. That's the Copernican principle that says we're not in anywhere special. And again, it's the center of the universe is everywhere because it was once a point.
Okay. Nice try though, Doug. Nice try. And thanks for the question. And happy observing. Gosh, I'm jealous. You've got some great gear by the sound of it.
Great gear, absolutely. It's terrific stuff.
Yeah. Awesome. Don't forget, if you have questions for us, go to our website, spacenutspodcast.com or spacenuts.io if you don't like typing too much and giving yourself a RSI. And you can upload your questions through the AMA tab or the Send Us Your Voice Message tab on the right-hand side. And while you're there, check out the Space Nuts shop and the Astronomy Daily tab and everything else. Lots to see and do on our website. And if you would like to become a patron, you can do that via the website as well. And thank you to those who do support us financially. It's totally voluntary. We won't force you to do that. And, we appreciate the support. Fred, we are done for another week, and thank you so much for staying up so late in Berlin. I know I appreciate it, and I'm sure everyone else does too.
Even if it is Munich. Yeah, that's right. It's
Munich. Did I say Berlin? Yeah. I'm obsessed with Berlin,
yes, I
am with Mars.
Yeah.
Well, only because I haven't been to Munich. I've been to Berlin. Lovely city. Really enjoyed it.
Yeah. No,
but yes. Thanks for staying up anyway.
It's all right. It's a pleasure. Next time we speak, I will be back in the study in Davidson in Sydney's Northern Beaches. So that'll be
wonderful.
Something to look forward to. Yeah.
All right. We'll catch you then. Thanks, Fred. See you soon.
See you later. Thanks. Thanks, Andrew.
Fred Watson, astronomer at large. And thanks again to Hugh in the studio, who hasn't done anything yet, but he will because that's his job eventually. And I'll catch you next time. Thanks for listening, and we'll see you next week on another episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.